Hello and welcome. In today's tutorial, we are going to solve these two simultaneous log equations step by step. To begin, let us look at this quantity, that is log to base 9 of x. Applying the change of base formula for logarithms to this quantity, we can write this as log₈x divided by log₈. These two things are exactly the same. The only difference is that while this is in base 9, this is in base 10. Now, the next thing we do is to divide both the numerator and the denominator of this fraction by the same quantity, which is log₈x. Because you know that when we divide the numerator and the denominator of a fraction by the same quantity, we haven't changed that fraction in any way. So we have log₈x divided by log₈x over log₈ divided by log₈x. Now log₈x divided by log₈x is 1. We can rewrite this denominator as log to base x of 9. Now remember that we started with log to base 9 of x. But now we have ended at 1 over log to base x of 9. So we can generalize this by saying that if we have log to base a of b, that it must be equal to 1 over log to base b of a. And this is a relationship that is going to be very important for us in solving these two equations. Because when you look, you can see that we have log to base 9 of x. And here we have log to base x of 9. Here we have log to base y of 8. And here we have log to base 8 of y. So that simply means that, for instance, if we decide to call this a and to call this b, then this is going to be 1 over a and this is going to be 1 over b. So we can rewrite these two equations as a plus b is equal to 2 and 1 over a plus 1 over b is equal to 8 over 3. Now we can solve these two equations for values of a and b. And then after we do that, we will now go back to these substitutions and get values for x and y. Now to solve these two equations, let us start with the second equation. We can combine these two fractions into one single unit. How do we do that? A times 1 is a. We have plus b times 1 is b. A times b is ab, and this is equal to 8 over 3. Now the next thing we do is to cross multiply. So we have that 3 times a plus b is equal to 8 times ab. But let us come to the first equation. We have that a plus b is equal to 2. So this is equal to 2. And then from the first equation also, we have that a is equal to 2 minus b. So here where we have a, we can replace it with 2 minus b. So basically what we have is that 3 times 2, which is 6, is equal to 8 into a is now 2 minus b, and we have b. The next thing we do is, this is an even number and this is also an even number, so we can divide both sides of the equation by 2. So we have this over 2 and this over 2. Here we have 3 and here we have 4 into, let us open this bracket, 2 times b is 2b minus b times b is b squared. So we have that 3 is equal to 4 times 2b is 8b, and 4 times b squared is 4b squared. Rearranging this equation, we have that we can bring all the terms over to the left-hand side, and when we do that, we have that 4b squared minus 8b plus 3 is equal to 0. So now we have a quadratic equation in b which we can solve for values of b. And we can factorize this equation. How do we do that? We simply multiply this term by this term. 3 times 4b squared is going to give us 12b squared. Now we ask ourselves the question, what are the factors of 12b squared that will add up to minus 8b? And of course, those will be minus 6b and minus 2b. Because minus 6b multiplied by minus 2b is going to give us plus 12b squared, while minus 6b added to minus 2b is going to give us minus 8b. So the next thing we do is to replace this quantity in this equation with these two quantities. And when we do that, we have 4b squared minus 2b minus 6b plus 3 is equal to 0. We can divide these two by 2b. So we have 2b. 4b squared divided by 2b is 2b. Minus 2b divided by 2b is minus 1. We can divide these two by minus 3. Minus 6b divided by minus 3 is going to give us 2b. And plus 3 divided by minus 3 is going to give us minus 1. And this is equal to 0. Now we collect the factors. We have 2b minus 3 multiplied by 2b minus 1 is equal to 0. From here, we have that either 2b minus 3 is equal to 0 or 2b minus 1 is equal to 0. From this equation, we have that 2b is equal to 3 and b is equal to 3 over 2. Or from this, we have that 2b is equal to 1 and b is equal to 1 over 2. So now we have two values for b, 3 over 2 and 1 over 2. And of course, we go back to the first equation, that is a plus b is equal to 2. From this equation, we can get values for a. Because of course, we know that a is equal to 2 minus b. So, when b is equal to 3 over 2, a is equal to 2 minus 3 over 2, which is equal to half. And when b is equal to half, a is equal to 2 minus half, which is equal to 3 over 2. So we have that the 2 points that satisfy these two equations are a, b, when a is half, b is 3 over 2. And the second point, a, b, when a is 3 over 2, b is half. Now, having found the values for a and b, the last thing we do is to go back to the substitutions that we made. So to calculate the values of x and y from these values of a and b, we go back to this substitution. And we have that log to base 9 of x is equal to a. Now, when a is half, log to base 9 of x is equal to half. Of course, when we have a statement like this, it simply means that 9 to the power half is equal to x. That is, 9 to the power half is equal to x. And of course, writing this in radical form, we have that x is equal to square root of 9. And since we are dealing with logarithms, we only take the positive square root. So this is equal to 3. So here we have that x is equal to 3. To calculate the value of y, we have that log₂y of 8 is equal to b. So when b is 3/2, log₂y of 8 is equal to 3/2. Once more, this simply means that y to the power 3/2 is equal to 8. That is, y to the power 3/2 is equal to 8. Now the question is, how are we going to calculate y from this equation? What do we do to make the exponent of y 1? Remember that when we have a raised to power m raised to power n, that this is equal to a raised to power m multiplied by n. So basically the question is, what are we going to multiply 3/2 by to get 1? And of course, that is the reciprocal of 3/2, because we know that 3/2 multiplied by 2/3, which is the reciprocal of this, is equal to 1. So what we are going to do is that we are going to raise both sides of this equation to power 2/3. So this is what we have. We have y raised to power 3/2 raised to power 2/3 is equal to 8 raised to power 2/3. On the left hand side, this will multiply to give us 1. And writing this in radical form is simply the cube root of 8 all squared. And we know that the cube root of 8 is 2 squared, and 2 squared is 4. So here we have that y is equal to 4. Now we do the same thing for the second point. Once more, to calculate the value of x from this value of a, we go back to this substitution. So we have log₂ of x is equal to a. Log₂ of x is equal to 3/2. And of course, from here we have that 9 to the power 3/2 is equal to x. Writing this in radical form, we have that x is equal to the square root of 9 cubed. Now the square root of 9 is 3. And 3 raised to power 3 is equal to 27. So here we have that the value of x when a is 3/2 is 27. We go on to calculate the value of y from this equation. So we have that log₂y of 8 is equal to b. And in this case, b is equal to half. So we have that log₂y of 8 is equal to half. Once more, this simply means that y to the power 1/2 is equal to 8. Now, we ask ourselves the question again, to what power do we raise both sides of this equation so that the left-hand side, which is y, becomes 1? Of course, that is 2, because you know that 2 times half is 1. So we have that y to the power half squared is equal to 8 squared. And from here, we have that y is equal to 8 squared is 64. We have that this value of y is equal to 64. So we have that the 2 points that satisfy these two equations simultaneously are x equal to 3 and y equal to 4, and x equal to 27 and y equal to 64. Now, to solve this system of equations, let us start with the second equation. And let us recall that when we have log a minus log b, that this can be written as log a over b. Now, with this in mind, we can rewrite the second equation as log₂ of x over y, and this is equal to 1. And of course, you know that when we have a statement like this, it simply means that 4 to the power 1 is equal to x over y. So from here, we have that 4 to the power 1, which is equal to 4, is equal to x over y. Now, cross multiplying, we have that x is equal to 4y. Now, let us move on to the first equation. Let us also recall that when we have a to the power log to base b of c, that this is equal to c to the power log to base b of a. Now look at the first equation. You will see that this is x and this is x. This is y and this is y. And the base of both logs are the same. That is base 8. Exactly as we have here. So it is safe to say that this first equation, x to the power log to base 8 of y, is equal to y to the power log to base 8 of x. And of course, when this is equal to this, we can of course write that this first equation is the same as 2 times y to the power log to base 8 of x is equal to 4. And of course, from here, dividing both sides by 2, we have that y to the power log to base 8 of x is equal to 2. Now, to further simplify this equation, let us take log of both sides. And of course, for uniformity, we are going to take log to base 8. So we have that log to base 8 of y to the power log to base 8 of x is equal to log to base 8 of 2. Now here we are going to apply the power law. That is that law that says that when we have log m to the power n, that this is equal to n multiplied by log m. So simply put, we can bring down this power to become a multiplier. So we can bring this down and have log to base 8 of x, that is this power, multiplied by log to base 8 of y, that is this. And this is going to be equal to log to base 8 of 2. But let us remember that x is equal to 4 times y. So here we have that log to base 8 of 4y multiplied by log to base 8 of y is equal to log to base 8 of 2. And now let us remember the product law. That is the law that says that when we have log a times b, that this is equal to log a plus log b. So this is equal to log to base 8 of 4 plus log to base 8 of y. And of course, everything is going to be multiplied by log to base 8 of y, and this is equal to log to base 8 of 2. Now let us simplify this equation. Here we have log to base 8 of 4. But let us remember that log to base 8 of 4 is equal to log to base 8 of 2 squared, because 2 squared is equal to 4. But then let us also remember that 2 is equal to 8 to the power 1 over 3. That is the cube root of 8 is equal to 2. So this is also equal to log to base 8 of 8 to the power 1 over 3 squared. Now, of course, you know that when we have two powers like this, all we have to do is to multiply both of them. So this is equal to log to base 8 of 8 to the power 2 over 3. But then let us remember the power rule. So with this rule, we can write this as 2 over 3 times log to base 8 of 8. And then let us remember that log to base a of a is equal to 1. So that means that log to base 8 of 8 is equal to 1. And we have that log to base 8 of 4 is equal to 2 over 3. So this is equal to 2 over 3. Now let us look at this. That is log to base 8 of 2. We know that this is equal to log to base 8 of 8 to the power 1 over 3. Because of course, the cube root of 8 is equal to 2. Once more, applying the power law, this is equal to 1 over 3 multiplied by log to base 8 of 8. And according to this, this is going to be equal to 1 over 3. So this is equal to 1 over 3. Now, to further simplify this equation, let log to base 8 of y be equal to a. So now we have that this equation is equal to 2 over 3 plus a multiplied by a is equal to 1 over 3. Opening this bracket, we have 2a over 3 plus a squared is equal to 1 over 3. And rearranging this equation, we have that a squared plus 2a over 3 minus 1 over 3 is equal to 0. Next, let us multiply through this equation by 3. And of course, when we do that, we have that 3a squared plus 2a minus 1 is equal to 0. And now we have a quadratic equation which we can factorize. We are going to use the table method. The factors of 3a squared are a and 3a, while the factors of minus 1 are 1 and minus 1. If we multiply 3a by 1, we are going to have 3a. And if we multiply a by minus 1, we are going to have minus a. And if we add 3a to minus a, we are going to have 2a. So that means that when we factorize this quadratic equation, we have a plus 1 multiplied by 3a minus 1, and everything is equal to 0. Of course, from here we have that either a plus 1 is equal to 0, and hence a is equal to minus 1, or 3a minus 1 is equal to 0, from where 3a is equal to 1 and a is equal to 1 over 3. So we have that a is equal to minus 1 or 1 over 3. And of course, from here we have that log to base 8 of y is equal to minus 1 or 1 over 3. And once more, remember, when we have a statement like this, it simply means that 8 to the power minus 1 is equal to y, or 8 to the power 1 over 3 is equal to y. From here, we have that y is equal to 1 over 8, or y is equal to 2, because the cube root of 8 is equal to 2. And of course, let us come back to this equation to find the values of x. Now, when y is equal to 1 over 8, x is going to be equal to 4 times 1 over 8, which is equal to 1 over 2. And when y is equal to 2, x is going to be equal to 4 times 2, which is equal to 8. So we have that the solution sets of this system of logarithmic equations are when x is equal to half, y is equal to 1 over 8. And when x is equal to 8, y is equal to 2. Hello and welcome. In today's tutorial, we have a system of logarithmic equations to solve, and we are going to begin with a substitution. Now, let logₕx be equal to a. And of course, from this statement, we have that 10 to the power a is equal to x. Likewise, let log₈y be equal to b. Once more, from this statement, we have that 10 to the power b is equal to y. Now, with these two substitutions, the first equation is going to be 3 to the power a is equal to 2 to the power b. The next thing we will do is to take log of both sides of this equation. When we do that, we have log₃ to the power a is equal to log₂ to the power b. And of course, here we apply the power rule of logarithms, and we bring down both a and b to become multipliers. That is, we have a times log₃ is equal to b times log₂. Now, if we divide both sides of this equation by log₃, we are going to have that a is equal to b times log₂ divided by log₃. Now, coming over to the second equations, with these two substitutions, we have 2 times. Remember, x is now equal to 10 to the power a to the power log₂ is equal to 3 times y is now equal to 10 to the power b to the power log₃. Opening up this bracket, we have 2 to the power log₂ multiplied by 10 to the power a times log₂, because of course you know that when we have two powers like this, we simply multiply the two of them. So this is a log₂ is equal to 3 to the power log₃ multiplied by 10 to the power b log₃. But now let us look at this and let us look at this. Of course, you know that we can write this as 10 to the power log₂ to the power a. And we can write this as 10 to the power log₃ to the power b. Of course, we have 3 to the power log₃, and here we have 2 to the power log₂. But now, written in this way, you know that 10 to the power log₂ is simply equal to 2, and 10 to the power log₃ is simply equal to 3. So this equation now becomes 2 to the power log₂ multiplied by 2 to the power a is equal to 3 to the power log₃ multiplied by 3 to the power b. Now, since these two have the same base, that is 2, we can add their exponents. So here we have 2 to the power a plus log₂ is equal to, the same thing happens here, 3 to the power b plus log₃. Now we can take log of both sides of this equation. When we do that, we have log₂ to the power a plus log₂ is equal to log₃ to the power b plus log₃. And once more, applying the power rule, we have that a plus log₂ multiplied by log₂ is equal to b plus log₃ multiplied by log₃. Opening up the brackets, we have a times log₂ plus log₂ times log₂ is log²2 is equal to b times log₃, plus log₃ times log₃ is log²3. But let us remember that a is equal to b log₂ over log₃. That means that here we have b log₂ divided by log₃ multiplied by log₂ plus log²2 is equal to b log₃ plus log²3. And of course, log₂ times log₂ is log²2. So here we have b log²2 plus log²2. This is over log₃ is equal to b log₃ plus log²3. Now let us bring this b term over to the left hand side of the equation. When we do that, we have b log²2 over log₃ minus b log₃ is equal to log²3 minus log²2. Now we can factorize b out of this expression. When we do that, we have b into log²2 over log₃ minus log₃ is equal to log²3 minus log²2. Of course, you know that this is over 1. The next thing we are going to do is to combine these two fractions into one single unit. Here we have b into log²2 times 1 is log²2 minus log₃ times log₃ is log²3 divided by log₃ times 1 is log₃, and this is equal to log²3 minus log²2. Now, of course, you know that log₂ and log₃ are constant terms, so we can find b in terms of both log₂ and log₃. All we have to do is to first of all multiply both sides of this equation by log₃. When we do that, we have log₃, and this goes. And then the next thing we have to do is to divide both sides of this equation by log²2 minus log²3. So here we have log²2 minus log²3. When we do that, this also goes. And we simply have that b is equal to this. But then look at the numerator and the denominator. We have log²3 minus log²2. And here we have log²2 minus log²3. Of course, you know that this over this is simply equal to minus 1. So we have that b is equal to minus 1 times log₃. And of course, applying the power rule of logarithms to this, we have that b is equal to log₃ to the power minus 1. And from our rules of indices, we know that this is equal to log₁ over 3. But now let us not forget that b is equal to log₁. So we have that log₁ is equal to log₁ over 3. So of course, from here we have that y is equal to 1 over 3. Now to find a, we already know that b is equal to minus 1 times log₃. So from this, a is going to be equal to minus log₃ multiplied by log₂ divided by log₃. Now, this is going to cancel that to tell us that A is equal to minus log₂. Once more, applying the power rule, this is equal to log₂ to power minus 1. And from our rules of indices, 2 to power minus 1 is equal to 1 over 2. But let us remember that A is equal to logₕ. So this is equal to logₕ. Of course, when log 1 over 2 is equal to logₕ, it simply means that x is equal to 1 over 2. So we found that x is equal to 1 over 2 and y is equal to 1 over 3. And these are the values of x and y that satisfy this system of logarithmic equations. And with that, we come to the end of today's exercise. I hope you enjoyed the exercise and I hope you learned something. If you enjoy such videos, please consider to subscribe. Leave us a thumbs up to support the channel. Thanks for watching and see you in the next one.